Mm.
The project is about architecture for dual mode floating point adder. Abstract. This paper presents a configurable dual mode architecture for floating point adder. The architecture is named QPDPD, quadruple precision with dual or two parallel double precision. It works in dual mode, which can operate either for quadruple precision or dual, that is two double precision. Literature survey. From the first paper, I have got the idea of floating point number and conversion of floating point number to binary and binary to floating point number. And from the second paper, I got to know that it gave the idea of proposed architecture algorithm, how it is going to work. And the problem definition is previously we have so many architectures for this dual mode adder, but it is taking more area and power, so it is occupying more it is taking more multiplexes. And the new proposed one, it has less number of architectures, so that it is trying to minimize the area and power. And the tools used for this is Model Sim and Synopsys 90 nanometer. And this is the basic of single precision, double precision and quadruple precision. Single precision we have mantissa 23-bit and exponent 8-bit and sign 1-bit. Like that in double precision we have mantissa 52-bit, exponent 11-bit and sign 1-bit. And in quadruple precision we have mantissa is only 112-bit and exponent 15-bit and sign 1-bit. This is the QPDPD adder architecture. First we have comparator, and then data extraction and subnormal handler, swapping, and then it is shifting, and dual mode add and subtract, and then again we have to do swapping, and then normalization, rounding. This is the algorithm for this floating point adder flow. Now coming to the each and every block of our architecture, this is the first subnormal handler, data extraction and subnormal handler block. This block it converts the normal input operands into the floating point format, like it extracts the sign, exponent and mantissa for both QP and DP mode. And beside we have comparator block. This comparator block, it will compare the two inputs. Next we have swapping block. It generates large sign, that is output sign bit, small and large exponent, small and large mantissa. And also we have one thing here. This is QPDP. Whenever that QPDP is 1, it will operate in quadruple mode, and whenever QPDP is 0, it will operate in dual mode. And then we have dual mode right shifter. The output from swapping, it is given to the dual mode right shifter. This right shift by the difference of large and small exponents. It's right shifting of small mantissa of QP or both DP. And then we have mantissa add and subtract. The large mantissa and right shifted small mantissa undergo add or subtract based on their effective operation. If sign bit, if we do XOR of two operand sign bit, if we got 1, then it will add. If we got 0, then it will do subtract. And then we will give that output to the mantissa sum and LOD. It provide actual sum for QP or DP, mantissa overflow and input for next level. And then we have leading one detector. It will do left shift. Mainly it is used for to check for underflow cases. And then the output is given to the dual mode dynamic left shifter. It is similar to the right shifter. It will do the right shifting. And then we have 1-bit left shifter. The output from dynamic left shifter is given to this 1-bit left shifter. Basically this is a normalization. It will do normalization if there is any case of overflow. And then last is we have ULP addition, and this is final step. It will combine together using guard bit, round bit and sticky bit, and all together it will give the output. And this is a whole summary. As a dual mode QPDPD adder architecture is proposed, which can process either a quadruple or dual precision addition or subtraction. This proposed architecture provides high precision computational support as well as SIMD support for the lower precision computations. The architectural subcomponents and data path are constructed for the configurable multi-mode operation, which enables efficient resource utilization with multi-precision support. This proposed dual-mode QPDPD architecture has smaller area and power. And this modification we are trying to this is here in while Mantissa edition they have used carry look ahead adder, and we are trying to modify this carry look ahead adder used for Mantissa edition in the circuit with some other fast adder for further improvement of area and power. And then these are the references. Thank you.